5, 4, 3, 2, 1.
Today's objective for this experiment is to determine both the volume and density of ball bearing and glass block.
The first step is we need to determine the zero error. The second step is we need to measure the diameter of the ball bearing. Keep in mind you need to turn the ratchet knob until you hear the click sound. Do not overturn the ratchet knob as this would cause damage to the micrometer. For the third step is you need to repeat step 2 at least 3 times at different position of the ball bearing. For the fourth step is you need to record all your data in a suitable table.
You must calculate the actual diameter reading taking into consideration to the zero error obtained earlier. And next, number 6, determine the weight of the ball bearing. And lastly, we must calculate the density of the ball bearing.
This is procedure for glass block by using vernier caliper. First, we count the whole number of small divisions on the fixed spot of the caliper that are to the left of the zero mark on the vernier. We do this because this gives you the size of the object to the nearest number of whole millimeter. Second, find the mark on the vernier that line up with one of the mark on the fixed spot of the caliper. The value of the mark on the vernier then tell how many fractions of millimeter are needed to complete the estimate of the size of the object. Third, determine the zero error of the vernier caliper.
Step number 4. Measure the length, width and thickness of the glass block by using the vernier caliper. Step number 5. Repeat step 2 at least 3 times at different position of the glass block. Step 6. Record all our data in a suitable table. Step 7. Calculate the actual measurement by taking into consideration of zero error obtained earlier. Step 8. Determine the weight of the glass block. Step 9. Calculate the density of the glass block.
So the question number 1 asks to calculate the volume and the uncertainties of the ball bearing and the glass block. To calculate the volume of ball bearing, we must use the formula 4 over 3 pi r to the power of 3. I put the data into the formula. So 4 over 3 times pi times 9.52 times 10 to the power of negative 2 and the power of 3. And the answer is 3.61 times 10 to the power of negative 3. So next, for the uncertainty, we must use delta V over V equal to 3 delta R over R. And the answer is 1.14 times 10 to the power of negative 4. So V plus minus delta V of ball bearing is 3.61 plus minus 1.14 times 10 to the power of negative 3. To calculate the volume of glass block, we must use the formula of length times width times height. And the answer is 1.0549 times 10 power of negative 4. Next, for the uncertainty, we must use delta V over V equal to delta L over L plus delta H over H plus delta W over W. And the answer I got is 4.4301 times 10 to the power of negative 7. So V plus minus delta V of glass block is 1.0549 plus minus 0.0043 times 10 to the power of negative 4. So for the question number 2, ask for calculate the density and the uncertainty of the ball bearing and the glass block. To calculate the density of ball bearing, we must use the formula M over V, which is mass over volume. And the density of ball bearing is 7.70 times 10 to the power of negative 1. So for the uncertainty, we must use delta P over P equal to delta M over M plus delta V over V. And the answer is 0.2. So P plus minus of delta P of ball bearing is 7.70 plus minus 0.2 times 10 to the power of negative 1. Next, for the glass block, we still use M over V, and the answer is 273.96 times 10 to the power of negative 3. For the uncertainty, we still use the same formula, and we got 6.80 times 10 to the power of negative 3. So, P plus minus delta P of glass block is 273.96 plus minus 6.80 times 10 to the power of negative 3.
So the discussion about the experiment is the experiment highlight the significance of accurate measurement in scientific investigation. Human limitation, instrument precision, and systematic errors were evident in the record data. Techniques like evergain and multiple trials improve the reliability of measurement, reducing error and enhancing precision.
By measuring the ball bearing's mass and volume accurately, we found its density to be 0.77 kg. Our method involved precise measurements using an electronic balance for mass and water displacement for volume. Our result aligned well with expected densities for similar materials, highlighting the reliability of our approach in determining density. And the conclusion for vernier caliper is: summarize the measured length and thickness, discuss any difference between measurement methods, reflect on the vernier caliper's precision. This streamlined setup guides the measurement of a glass block's length and thickness using a vernier caliper, emphasizing accuracy and consistency in readings. Adjustment can be made based on specific experiment criteria.
Hi, Assalamualaikum. My name is Muhammad Daniel Azman, and today's experiment is experiment 5. For today's objective, to determine the coefficient of state friction of different surface.
Theory/introduction. Force and velocity are vector quantities that have both magnitude and direction. Velocity is the speed in a specific direction with which a given object is traveling. Force exists when the object accelerates or undergoes a change in its velocity. A body at rest or in equilibrium exhibit resultant force, or the sum of all force acting on the body is zero. Gravity is an attractive force that exists between two masses.
So, the apparatus is a wooden block with rubber covered at one side, 50 gram masses, 10 Newton spring scale, and string and tabletop.
Experiment 5. So, firstly, we must measure the mass of wooden block we call as M. Secondly, we must set up the apparatus as shown in figure 5.2. Thirdly, make sure the tabletop is stable and horizontal to the ground. Number 4, attach the spring scale and the wooden block with a string. Place them horizontally on the tabletop. Make sure the rubber side of the block is face downward. And 5, and place a M equal 50 gram mass on the wooden block. Number 6, pull the spring slowly once the block start to move. Record the spring scalar reading and record the value as F and tabulate in the table 5.1. And number 7, repeat step 4 until 5 for 3 tiles. Add another 50 gram mass on the wooden block and repeat step 5 to 6. Repeat the step until the total of M equal 500 gram mass in on the wooden block.
First of all, we calculate the mass of wooden blocks. After that, we mix the mass between the wooden block and the mass that is m plus m. For weight, we divide it by 1000 from the answer we get from m plus m to convert it to newtons. We tried 3 atoms and found the average. Then we repeated the experiment by adding a lot of 50 gram to reach 500 gram.
Okay, for the discussion. Based on the result of the experiment, the non-rubber surface have a greater coefficient of static friction than the rubber surface. The plot graph shows that the coefficient of static friction for a non-rubber surface is higher than the rubber surface. Third, the experiment may have a few errors that are due to the carelessness and parallels error during conducting the experiment. In order for us to minimize the error, the observer eye have to be perpendicular to the spring scale to avoid reading error. Other random errors that can be found are caused by the uneven surface of the table that we use. This error can be prevented by measuring the spring scale numerous times and averaging the result.
So, the conclusion is, in this experiment, we found out how important friction is in our daily movements. Friction is like a brake that stops things from sliding endlessly because it opposes motion. We learned about two types of friction: static, which stops something from starting to move, and kinetic, which slows down moving objects. We also noticed that the area touching the surface didn't change how much friction there was, but to get a steady friction value, things needed to move at a steady speed. This matched what Newton's first law says: if something has no force acting on it, it will keep moving at the same speed. By gently pulling the spring scale, we made the wooden block move to reduce static friction because things in motion have less static friction. We discovered that no matter how the heavy block or the hanging mass was, the friction remained the same. The graph we made showed that as one thing got heavier, the other did too, in a balanced way.
I think we already reached the end of this video, and thank you for watching our video. Have a nice day.